Alright, so hello there ROS developers, sorry for this delay, I had some problems here, but I think everything is fine now. So welcome everybody to this live class number 94, where we are going to be talking about machine learning for robotics, in specific some basic concepts about the linear regression algorithm. So yeah, let's go for it. So hello there and welcome everybody to this live class number 94. So I hope everything is fine. You can see me properly and you can hear me properly. Please let me know in the chat so that I can be sure that everything is fine and I can keep going with the class. So I'm going to read the chat now in a moment. So as I've said, today we are going to be introducing a little bit of machine learning for robotics, in specific about the linear regression algorithm. Very basic concepts, but I have to tell you that we are preparing a complete course for machine learning for robotics, where we will be discussing much more about the linear regression algorithm, neural networks, etc. It's going to be out there in the academy very, very soon. So stay tuned for that. This is just a teaser, a very small teaser of that course. But yeah, let me see the chat here. Super, yay! Excited for today's session. Hi, really fine. Intro is super cool. Thank you, thank you very much. Fine. Audio and video are good. Everything good. That intro is very nice. Okay, I see that this intro is liking a lot, is being very liked. Okay, very clearly, hello. All right, excellent. So let's go for it then. Everything is fine, sound is fine, image is fine. So let's go for it. Then I'm going to switch right now to my computer screen and we are going to start. Let me first get a bit of coffee here, as always, from my ROS developers fancy Mac. There we go. Let's go, let's start. So, as always, first of all, the first thing I'm going to do is to share with you guys the ROSject. So let me refresh here so that I can see my ROSject for today's live class here. And there we go. So let me share here the link with you in the chat. There we go. Okay, so as always, just get the link. I have just passed it into the chat, and you are going to get this ROSject for today. By the way, I can see here it says live class number 98. This is a typo, of course. It's live class number 94 today, not 98. Let me update this. There we go. Okay, so as always, just click on the link and you are going to automatically get this ROSject in your workspace. If you have a ROS developer account. If not, just create an account. It's free. You are going to do it in a few seconds, and then you are going to be able to access here this ROS Development Studio, and in your workspace, in your My ROSject section, you are going to get this ROSject for live class number 94. Yep. Then, as always, first thing is to open the ROSject. Click here on the open button and then open the ROSject, which is going to start loading all the environment. Yeah. This has kicked me out for some reason here. All right. There we go. So now I think it should be loading. I don't know why I got kicked there in a moment, but yeah, it is being loaded. Here I can see that the project is being loaded. So meanwhile, as always, let me talk with you about basically one thing today. I just want to keep remembering you guys about the ROS Developers Day. Let me come here to the webpage, and I'm going to, in fact, share with you as well the link here in the chat so that you can access it as well. So basically, let me just verify that this is loading properly. Yeah, okay. Then, so we are super close to the third ROS Developers Day, which is going to be held in June the 27th. So in just 20 days, we are going to have this super awesome conference. In this case, it's going to be one single day. In previous editions, we did it in 2 different days, Saturday and Sunday. But in this edition, we decided to make everything into one single day. And it's going to be a conference, a day for ROS developers. So you are going to be listening to different conferences. You can see here a list with some of the speakers we are going to have there. And what is the title of their speeches, what they are going to talk, the times at which each conference, each speak is going to be at. So we are going to have basically many interesting conferences and speeches about different ROS topics, and they are going to be made by ROS experts, different ROS experts of different areas. So it's going to be super interesting. So guys, if you want to spend this day with us and learning a lot of ROS and practicing a lot of ROS, because these conferences are going to be in the same format as a live class. So the speaker is going to explain whatever it needs to be explained, but then we are going to be practicing what we learn into the simulation, into a simulated robot, yes, which is our way of teaching and the way we think it's better for teaching, yes. So you are going to learn a lot of ROS, and you are going to be able to practice a lot of ROS, yes. Then now in the project, I'm going to share with all of you guys. This has already loaded, so let me close all this, and let me make this project here bigger. So I want to, today I wanted to share with you a coupon, a 5% discount coupon for this ROS Developers Day. Yes, here you have the code, the coupon code, and it's going to be valid until June the 14th. Yes, so here once you open the project, here in the notebook, you are going to find this coupon code, which you can use in order to register here for the ROS Developers Day with a 5% of discount. Yes? So, great. That's all I wanted to talk. Also, my project is already loaded, so I'm ready to start. Then one thing I want to make sure is that all of you guys have been able to load the project without problems. Let me know there in the chat as well if everything is fine, project is loaded, yes, no. Loaded, fine, loaded, okay. Yes, loaded. Oh, Mikael says, I registered it yesterday and missed the 5% discount. Never mind, okay. Yeah, that's really bad luck. But yeah, we'll see you in the conference day then, Mikael. Loaded. Okay, so everybody has the project loaded. Excellent. Then great. Let's start. Let's start. So as always, a couple of requirements. In this case, basics, Linux concepts, and basic Python. So we are going to be generating some Python scripts and working with some command shells, Linux command shells. So that's why we always we always set these two courses as requirements. You can check them in our academy. They are totally free, so you can start them and complete them for free. And also for today's live class, we are going to be working with a simulation. So next thing to set up is the simulation. For this, you just need to come here to the simulations menu here at the top bar, and then select from the list of worlds. You can come here, and in this case, we are going to select the empty plus wall. Yes, here you have the empty plus wall world. I'm going to select this one, and for the robot, I'm going to select the turtlebot 2, which I have here at the bottom of the list of robots. There we go. So the combination is this one. For the world, the empty wall world, and for the robot, the turtlebot 2. Then once I have selected both, I can click on the Start Simulation button here, and this is going to start loading my gazebo simulation. Yep. There it is going. Alright, so here it's loading my simulation. Here you have all the data. I have just explained it in case you want to refresh it. The world you have to select, the robot, and what you should get at the end. So here I have my simulation being loaded. Excellent. Let me make this a little bit bigger and put this at the right side of the screen. There we go. And here I have my turtlebot robot with this wall in front of it, which is the world I am going to be working with today. Yes, so great. Once this is loaded, we are going to be ready and set up for start with the project. Yes, so let me know as well, guys, if you had any problem here with the world, if you are at the same point as I am, here with the project loaded and the simulation also prepared. I always ask you about this because I'm very interested in you practicing with me. Yeah, so I don't want you to be there at your computer just listening to me or watching at what I am doing here in my project, but I want you to listen to me, of course, but at the same time practice with me. So everything I will be doing here, you will see that I will be generating code for the robot. I'm going to be also executing some Python cells here to generate plots, etc. So I want you to be practicing with me, yes, so that we all together are doing the same and progressing in the same direction. Yep. Spawning, I can see here loaded, says Juanba Romance. Loaded, says Lins as well. Okay, great. So I see people is starting to get set up with project and simulation. Excellent. Loaded also. Still loading, still spawning. Okay, it's going to take just a few moments, so don't worry about that. It's perfectly fine. Loaded, still spawning, loading. Okay, don't worry. I'm going to start doing the explanations because it's going to take up to 1 minute to load the simulation, so that's not a big deal. Yes? Then, first of all, machine learning. What is machine learning? Everything knows what machine learning is. Well, in our case, we know as machine learning the scope. It's a scope, a section of. We can understand machine learning as a section of artificial intelligence, which creates systems that are able to automatically learn by themselves. Yes. So this is the main point. Then by learning in this concept, we don't mean as we humans understand learning, which usually, I don't know, it's to open a book and start reading. No, by learning what we refer is that these systems are able to identify patterns from a given dataset. Yes, this is what we understand by learning. Yes, so the system receives certain data and then analyzes this data and is able to detect patterns within this data. Yes? So basically, So yeah, so basically this system basically is going to analyze this data, and based on this analysis is going to try to predict future behaviors of the system. Yes, this is the main goal of machine learning, to analyze a given data and with that data detect patterns and be able to predict future behaviors of the system. Yes? Then, okay, so machine learning is huge, so it has many concepts to be discussed inside machine learning, but in this case, in this live class, we are going to focus on linear regression, yes, which is a small part of machine learning, but we are going to be focusing on that because our time is limited, and even though we are not going to be able to discuss all the parts which take part in linear regression, you are going to see in a moment. But basically, let me, 1 second. Is there? Let me have a quick look because I have started talking here and okay, is the robot Turtlebot 2? Yeah, Usman, the robot is Turtlebot 2. Yeah, Botman is saying deep learning via neural networks, convolutional neural networks on images are amazing too. Yeah, Bot. So let me tell you that in the course we are preparing, we are going to have a chapter about neural networks. So they are not going to be included into this class, maybe in future live classes, I don't know. But in the course we are going to be talking and discussing about neural networks. So yeah. Yeah, Turtlebot 2. Okay. ROS is cool for the ready tool and technique that must learn for about years, like path planning in mobile and ARM. Yeah, that's true, Minute. That's true. Okay, so linear regression. Okay, first of all, what is regression? Well, regression is a method of modeling a target value based on independent predictors. Yeah, so basically the regression method is used for finding out cause and effect relationships between variables. Yes? Then linear regression specifically is a type of regression which where the number of independent variables is 1 and there is a linear relationship between the independent and dependent variable. Yeah, so there is a linear relationship between the variables. Yeah, this is very important in linear regression. Then based on the given data, set, with linear regression, what we are going to try to do is to plot a line that models the points the best. Yes, you are going to understand this better in a moment when we start doing some examples. Yeah, but basically is this. So from given a data set, given a set of data, we are going to try to create a line which best predicts the future behavior of the system. Yes, basically this is the general idea of linear regression. Then, for instance, let's talk here about a typical or a practical example in a robot. So let us all think that we are in a lab and we have a manipulator robot. Yes, a manipulator robot, a robotic arm. Yeah, whatever you want. You can imagine any arm you want. Yeah, so let's imagine this scenario. Yeah, we are in a laboratory and we have this robotic manipulator. Then basically we want to test the relation between, well, we want to test the measurement of the emergency stop length distance. Yes, so once we click on the, well, most of you probably know that most robots, manipulator robots especially, have an emergency stop button. So in case for any reason maybe, I don't know, the arm manipulator gets out of control and it can hurt somebody, then you can press this emergency stop button and the robot is going to completely stop. Yes, this is a very typical behavior in mobile manipulators, etc. Yes, especially useful if they need to work in an environment with humans, for instance. Yeah. Then basically we want to do some tests in order to measure the emergency stop length distance of our robot. So when we click on this emergency stop button, how much distance the robot travels until it completely stops. Yes? Then during this test, we press this emergency stop button while it is moving many times. So we send movements, trajectories to this arm, and then we press the emergency button, and then we get the data of how much the robot has traveled before it completely stops. Yes? And then we repeat this test for different scenarios. Then the parameters for our tests are going to be the angular speed of axis 1, in this case, and the payload. Yes? So what is the extra mass, let's say, that the robot is carrying? So let's say that our robot has a tool in its gripper. In this case, the gripper can be a hand, for instance, and it has a tool. Yes? Then this tool can be heavier or lighter. Yes? And of course, depending on this extra mass, the stop length, the emergency stop length, can vary. Yes? Then this is one of the parameters of our tests, and the other one is going to be the speed at which, the angular speed in this case, at which the axis 1 of the robot is moving. Yes, they are going to be the two parameters in our tests. Then, let's say that, for instance, we perform 45 tests with different speeds and with different payloads in our robot. Yeah. So in order to get a amount of data, we send trajectories at different velocities and we change the tool of our robot so that the payload and the extra mass also changes. And with all this, we get a set of data. Yes? So, yeah, more or less. Are you following? Let me see the chat here. Okay, I can see. I don't know if I can see someone here talking about Minecraft, which it's funny. Yes, big yes, following. By the way, let me tell you that if you are waiting for me to play Minecraft here in the live class, I'm not going to do it. Yeah, so for that, I'm sorry, but it's not in the schedule of this live class to play Minecraft. Yeah, following clear to me, makes sense so far. Okay, great. So let's keep going. All right, then, okay, so we have generated a set of data. However, our lab has limitations. Yes, it can have limitations. For instance, it is too small, or for instance, it's too small to perform tests with higher speeds, or it's too small to move the robot around. I don't know. So let's say that our lab has some limitations in order to get a bigger set of data for our test. Yes, then for this case, what we can try to do is to apply linear regression in order to, since we cannot do the test ourselves, we can try to predict what would happen or what would be the emergency stopped length distance if the speed was even higher, or if the mass was even higher. Yes, for instance, we don't have a tool which is in our lab, we don't have a tool which is super heavy, but we would like to know what would happen if our robot was carrying this super heavy tool. Yes, then for this we can apply linear regression, and given the data we already have, try to predict what would happen if we apply even higher speeds or if we apply even higher payloads to our robot. Yes? Makes sense? Then for this we could use linear regression. In this case, the equation we would be something like this. So the stop length would depend on the speed of axis 1 multiplied by a certain weight and the robot payload multiplied by a certain weight. Yeah? So our stop length would depend on this summatory here. Yes? Then basically, as I've said, linear regression basically tries to find a linear relation between variables. So at the end, what we would have is this equation. This is the equation that represents linear regression. As you can see, this is the equation of a line, of a straight line. Yes? So if you have done basic mathematics, you will know that this equation goes for defines a straight line, like the one we have here. Yes? Then basically here we have a graphic representation of linear regression where we would have all these points are the measurements, so the data we have, the data sets, the values. So in our case, for instance, this could be the stop length distance of our robot. Yes? Then for all this data, we try to define here the regression line, which is based on the data we have. Yes? So this would be our line. Yes? And then from our line, we have two parameters. One is M and the other is B, which we have here, M and B. Yes, then M basically is the slope of our line. So it's the increment in the y-axis divided by the increment in the x-axis. Yes, M is the slope, the inclination of our line. And B is the position of the line. So B basically is the position in the y-axis at which our line crosses. Yes? So if the line continues, it would cross with the y-axis somewhere around here. Then this value would be the B value. Yeah? So basically a simple equation of a straight line. Yeah? Makes sense? Then here we are going to run here this Python code, this cell, which is going to basically, it's just a demonstration using matplotlib, sorry, of this. This is an image, and here we are going to generate this ourselves. So in this case, basically what we are going to do is to estimate temperatures. Yes, temperatures for each day. So in this case, what you have to do is to select the cell. You can see here that I have my cell selected. Yes, if I come here, this gets this blue border. Yes, so if I come to this cell, then this one is going to get the blue border, and then at this point I can click here on the run button, and this is going to execute my cell. Yes. The first time you execute it might take a little bit longer because it's importing matplotlib and it is importing all the libraries and everything. So maybe this takes a little bit longer. Then from this point everything is going to be generated much more fast. Yes? So just let's wait a few seconds. Okay, in case you get this message, this can happen. As you can see here, I get this message, figure size 100 multiplied by 800 with one axis. Okay, in case you get this, just select again the cell and rerun. Yes, this is an issue that sometimes happens only the first time you execute it. I guess it's because it's taking too much time in order to import everything. But if you get this, just run again the cell and then it's going to work properly. There we have it. Yeah. All right. So as you can see here, we have generated a very simple plot with the temperature values here in one axis and the days here in another axis. Yeah. So let me have a quick look here at the chat. Okay. Got it. Plotted. Okay, great. So I see you guys are being able to follow it without problems. Excellent. I see Gloria is having some kind of problem, but Ricardo is already there supporting, I think. It works. Done. It works. All right. Great. So yeah, here we can see a very simple example with the days, the temperatures, our data set that we have, and the regression line that we are predicting here. Then with this we can say that for day 12, more or less we can expect a temperature of 26 degrees, or well, something more, 27 degrees or something like that. Yes? Then considering the line in the above figure, we can estimate the temperature around 27 degrees. However, here this is a very rough estimation, yes, because in this case we are only considering the first point and the last point. Yes, we are only considering this point and this point in order to generate our line. Yes, so this is a very rough estimation. Yes. Then in this case here, what we are going to do is to generate again this data, but for the example we were discussing at the beginning. Yes, which was the one with our arm and the stop emergency stop distance, etc. So again, let's come here to this cell and run it very quickly. There we go. All right. So here we have the data set that we currently have for our robot. Yes. So here we have a percentage speed for the axis 1 of our robot, and here we have the stop distance. Yes. Then here is all the data we have until now. Then as you can see, and also you can see from this figure, from this previous figure, so there is an error here. Yes. So this line at this point is going here. Yes. Our prediction line at day 4, it's passing at around 23 degrees, but the current data, it's not 23 degrees, it's 26 degrees. Yes, and the same happens here. Yes, so there are some values in day 6, for instance. Our line has predicted a value of a temperature of 24 degrees, but the actual value is much lower. Yes, it's 18 degrees. So as you can see, there is some error that can be up the line or down the line, or down our regression line. Yes, then so some of our data set points are below and some are above our line. Yes. Then in order to summarize this error correctly, first of all, we need to remove negative values. Yeah, then for that, what we are going to do is to square our error. Yes, and at the end, once we have squared our error, we can do a summatory of all our errors and divide it by the number of points of data sets that we have. Yes, and this is going to generate a very known mathematical formula, which is the mean squared error, or also known as MSE. Yes, so basically this is nothing that the error of our regression line. Yes, so given our line, which we have here, we can see that some points are different from our line. Yes, then basically we can calculate this error and sum all together these errors and divide it by the number of measurements, of data sets, of points that we have. Yes, then this is going to leave us an equation similar to this one. Yes, basically just get this general idea of the regression line implies some error, which is obvious, you can see here from all the examples, and we can calculate this error with the MSE, the mean squared error formula, which is this, yes? So basically it's a summatory, as you can see, this is a summatory of all the errors, yes? The difference between the current point and our line, it's a summatory, this is a summatory of all these errors squared, so that we don't have negative values, and then divided by the number of measurements that we have. Yes, this is the basic equation for the mean squared error. Yeah? Okay, let me have a quick look here at the chat. Okay, I see that here there is some problem with Gloria, which is being discussed right now. Okay, well, I don't know. I hope that you can solve it, Gloria. It's strange because usually you are always here and you are not having problems. Okay, so. Okay, so basically, in order to, so as I've said before, the main objective, then, once we have defined our line, our objective would be to try to get the minimum value for the mean squared error, yes? So, the lower our error is, the more accurate our predictions, our line would be, yes? This is why at the beginning we said that in linear regression what we're going to try to find is the best fitting line through our test results. Yeah, so the best fitting line. Basically, the definition for this, the best fitting line, is the line which has the minimum error from the line values to our current values. Yeah, makes sense? Then our goal would be to have the minimum value for the mean square error, right? Then that would make our line the best fitting line. And for this, basically, what we have to do is to calculate the optimal, the best possible values for M and for B, which are the values that basically are going to define my line. Yes? Then for this, there is one method in linear regression which is called gradient descent. Yes? However, we are not going to go through this on this live class because it's a complex concept, and maybe we can discuss about the gradient descent. I don't know if you guys know about this method or not. Maybe we can do it in another live class, because only this, it would take all the time for one single class, because it's a complex topic. So we are not going to talk about it in this live class, but basically I want you to get this concept, yeah, the main idea, yes? So in linear regression, we are going to generate the best fitting line. Then in order to be the best fitting line, so the one that assures that we have the best predictions, we have to make sure that our mean square error, our difference between the real measurements and our line, is lower as possible, yeah? So our error is minimum. Then for this, basically, what we have to do is to find out our optimal M and B values, yes? So that our line is the best fitted line. And for this, we can use the gradient descent method, yes? Which we are not going to discuss today, but I don't know. Maybe we can talk about it in future live classes. Then finally, I just want to execute as well this other Python cell. Let me execute it here. And this, as you can see, basically from the dataset that we generated of our stop distance, we generate the line here, and even we can see here the error between each real measurement and our line. Yes? We can also run these cells here in order to get the coefficients m and b. Yes, so in our case here, the b coefficient, remember the m and b coefficients, I explained them at the beginning. Yeah, the m is the slope of our line and the b is the position in the y-axis in this case at which our line crosses the axis. Yes, so for instance, the b value we can see very clearly here. Our b value is 5 dot something, yes, because our line is crossing in the axis at the 5 dot something value. Specifically, we can see here that the value is 5.39, yes? And the m, the slope, the inclination of our line, in this case, it's 0.16, yes? So basically here we are calculating the m and from our model that we have generated here, yes? We are calculating the m and b values, yes? Then in order to make this line the best possible line, what we will need to do is to make sure that this error is the minimum possible. Yes, this the mean square error is the minimum possible, and for that what we would need to do is to play, to modify, to find out which are the best possible m and b values for our line. Yeah, more or less. Then with this data, now we are not going to do this to optimize it, but with this data, with our regression line now, we can approximate and we can try to predict, for instance, what would be the emergency stop distance if we apply a velocity of, let's say, for instance, 90%. Yeah, we don't have data about 90% or 100%. We don't have this data, but with our line, our regression line, we can try to predict these values. Yes? For instance, in this case, if we apply a speed of 90%, we would get a value approximate of 20 more or less. Yes? And for 100%, we would get a 20 something value. Yes, we can we can predict this with the exact number here in this cell. By executing this cell, you will get these values. Yes, so for 90%, we would get 20, and for 100%, we will get 21.7, more or less. Yeah? All right, so now we have explained all these concepts. We have seen also some graphics here, some plots generated with matplotlib that I think they help a lot to better understand the concept. So now we are going to basically do this and generate a very simple and quick practice with our robot, with our simulated robot. Yes? Then for this, let's open a shell here. And we are going to, first of all, create a package inside our Calculus workspace. Here we are going to create a package called linear regression. Yes, so let me come here and copy this command and paste it right here. There we go. Okay, so now I have generated my package. Let me come here and open it here in the IDE. And now inside this package, what I'm going to do is to create two new Python scripts. One is this one, which is called captureDataset.py, and the other one is this one, which is called moveRobot.py. Yes? Then let me refresh here the IDE and see if it loads properly now. All right, so here we are. I'm going to open my Calculus workspace. There we go. And inside the src folder, I'm going to find my linear regression package. Yes? Then inside the src folder, for instance, I'm going to generate here a new file, which is going to be called captureDataset.py. There I have it. Then within this script that I have just created, I'm going to copy and paste the code I have here in the notebook. So let me come here and select here all the code. There we go. All right. Let me paste now this code here. Excellent. And now I'm going to basically do the same with the move robot. So let me first of all copy here the code very quickly. There I have it. And then I'm going to generate here the script as well. New file, move robot.py, and paste the code here. All right. So I have created my package and I have created my two scripts. Then let me very quickly review and explain what these scripts do. So basically this move robot script is a Python class, as you can see, which the only thing that does is to publish commands into the command belt topic. Yes. So here we are generating a ROS publisher for the command belt topic. Here we have the send command function, which basically is going to set certain values to the velocities. Yes, it receives the linear velocity and the angular velocity, and then with these velocities is going to call the publish once in topic, which is this function, which is going to publish the message. Yes, so basically this is a support class that is going to publish velocity messages to our robot in order to move it. Yes, this is basically the purpose of this move robot by. Then our capture dataset Python script is the most important one here. So in this script, what we are doing first of all is to subscribe to the ODOM topic. Yes. So we are creating here a subscriber for the ODOM topic. And here we have the callback for this odometry topic. So each time a new odometry message is published into the topic, this callback function is going to be triggered. Yes. And then this callback function, what does is basically to capture the position of the robot in the x-axis and the position of the robot in the y-axis. Yes? So it's capturing data about the position of the robot, where the robot is in the simulation. Yes? It's capturing the value of the x position and the y position. And it's saving this data into these variables, xx and yy. Yes? And then it's writing these values into a file. Which file? This one. Here, in our Kakin workspace, we have this results folder, and then it's going to write this data, the data about the position of the robot in the x and y axis, into this file, into this test.csv file. Yes? Then it's going to start recording all the data that it's capturing from the ODOM topic into this file. Yes? And then finally, the other thing we have is just a call to the send command function of the move robot pi. So basically here what we are doing is to set a linear and angular velocity and move the robot by using these functions that we have in the move robot class. Yes? We define some velocities and we send them to the robot so that it starts moving. Yeah. Then while the robot moves, in this case the movement it's going to do it's forward, because we have a linear velocity, and it's going to turn a little bit here to the left because we are applying as well here an angular velocity. Yes. So the expected behavior of the robot is going to start moving forward and turning a little bit to the left until it's going to collide with the wall. Yes, it's going to collide with the wall and it's not going to be able to go forward. Yes, this is the expected behavior. And while the robot is moving, is doing this movement, we are going to be capturing the data about the position of the robot in the x and y values and saving this data into the test.csv file. Yes? So this is basically the experiment that we are going to do right now. Then let me run it. So let me come here and well, first of all, let me make sure that my Python scripts have execution permissions. Let me open here the linear regression package, and they don't have, so I'm going to do a chmod in order to give execution permissions to these files. There we go. And now I'm going to execute my capture dataset script in order to start moving the robot and capturing the data. So first of all, let me source my workspace with this command here. Let's go here to the src folder of our workspace, and let's execute this ROS run command in order to execute our script. There we go, executing. Then we can see here that our robot starts moving. Yeah, don't worry about this. I'm going to refresh. It's only the visualization. So we can see here that our robot starts moving, turning to the left until it collides with the wall. Yes? And meanwhile, here I can see the data, which has now stopped. So I'm going to stop with Ctrl+C my program. Yes? Then all this data, this is the value of the X position, and this is the value of the Y position of the robot at each time. You can see how it's been, it modifies while the robot moves. Now it didn't modify anymore because the robot is stuck here against the wall. Then all this data has been saved as well into this file, into the test.csv file, as you can see here. Yes? Then what we are doing to do right now is to plot this data. We are going to do this with this cell here. Yes? So as you can see, with this cell, we are going to access this file, the test.csv, and we are going to plot it. So let me execute it so that you can see it. There we go. So here we have the plot. Yes? So the robot started at the 0, 0 position, and here we can see the value in the x-axis and the value in the y-axis. So this is basically the movement that the robot has been doing and that our dataset has captured. Yes? So, for instance, for when the x position of the robot was 1.5 meters, the y position of the robot was more or less 0.4 meters. Yes, this is the data set that we have captured, the real data that we have captured here from our robot. Yeah? Then with this, we can create a linear regression. And we are going to do this with this cell code here. Yes? So let me run very quickly this cell here. It's still generating the plots and everything from the data we have. And there it goes. It has finished it, I think. Yeah. Yeah, so in this case, as you can see, this is our data, and this would be the regression line. Yes? However, as you can see, it's inaccurate. Yes? So this would be the difference between the lines here and between our current points and the regression line would be the error. Yes. However, here we are applying linear regression, but it would be better to apply multiple regression for this case. Yes. However, this would fall outside the scope of this live class again. So we are going to leave it like this with our data, our linear regression more or less calculated. Yes. And yes, this would be basically all for the live class of today. As I've said, this is only a teaser of the machine learning for robotics course that we are preparing. It's going to be in the academy very soon, probably next week or around there. So stay tuned, because right there you're going to be able to learn much more about linear regression, multiple regression, neural networks, as some of you already said in the chat. So it's going to be a super interesting course. And yeah, for today's live class, this is everything. I hope you enjoyed it. You've learned something new. What is the ROS command to reset the robot again? Says Engineering Nation. Okay, in case you want to reset the robot, engineering, what you can do is to call the service, ROS service called gazebo reset world. Yes, ROS service call gazebo / reset world. Then here you press the tap button, and this is going to reset the world. Yes. In this case, it has also moved here the wall, but you can just turn it again like this. Yeah. But this is basically the command in order to reset the world. Did you create a package under Cooking Workspace SRC? Yes, Herbert, I have created a package. Here you have the instructions here at the beginning, the command and everything. Yes. So I have created this linear regression package in my Cooking Workspace. Yes. Here I have created this package and I have placed these two scripts, the capture dataset and the move robot. I have also created these scripts and put them inside this package so that I can execute them. Yes, so the package I have created it. It's not provided with the project of the live class, yes? You have to create it yourselves. Thank you for the tech support, Gloria Felix. I got into the project. It's extreme internet, okay, well, at least, as always, you are going to be able to review this video, Gloria, and test the project and everything later at your own pace, so don't worry. Thank you. Good class, says Penelope Lianidu. Thank you very much, Penelope. Thanks again. Looking for ML neural networks for robots. Okay, very soon, Helder, very soon. Alright, so thank you very much, guys. Thank you very much for spending this hour with me. I hope you had a good time at least, and that you have learned something, even if it's something little. I would be happy if you have learned something from this live class. And yeah, thank you very much, guys. Let me go back to my camera view here. Thank you very much, guys, and I will see you again next Tuesday in next live class. And yeah, thank you very much. As always, as I always say, stay safe, keep staying home, depending on the situation of your country, of course, but try to stay safe. And yeah, keep pushing your ROS learning. Bye bye, see you next week.